Construction work on the Burj Khalifa was underway. The entire structure had more or less been raised, and now it was time to install the window panels. The engineers thought there was nothing too complicated about installing window panels, so they didn't pay much attention to it. But then something happened that nobody had expected. Dubai's extreme heat, combined with the enormous height of the building, created a serious problem for the installation team. The heat and intense sunlight made working on the unfinished building extremely difficult. And the problem became one of the biggest challenges faced by the construction team. Because of this issue, work on parts of the interior was affected while engineers searched for a solution. For a long time, the team struggled to solve the problem. But eventually, they found a way to move forward. Welcome back to another video from Zirk TV. The Burj Khalifa in Dubai is the tallest building in the world. Standing at 828 meters, this incredible tower rises above the clouds and cost approximately $1.5 billion to construct. But it wasn't just the enormous cost that made this building special. It became one of the greatest engineering achievements in modern history. How did engineers, architects, and workers actually manage to build such an enormous structure? What difficulties did they face during construction? And how did they find solutions to those problems? That's exactly what you are going to discover in today's video. So, let's begin with the first challenge. Challenge number 1. One of the first major challenges was completing the Burj Khalifa within the required construction schedule. Building a tower of this scale required years of design, engineering, planning, and construction. But if the team had waited for every detail of the design to be completed before beginning construction, they would have lost valuable time. So, the design and construction processes had to continue together. Excavation work officially began in January 2004. While engineers and architects continued working on the design of the tower, this allowed the project to move forward much faster. But once the excavation began, another major problem appeared. Challenge number 2. When the time came to build the foundation, engineers had to deal with Dubai's sandy ground. Normally, extremely tall buildings require foundations capable of transferring their enormous weight deep into the ground. But the Burj Khalifa required something far more sophisticated. So the question was simple. Could the ground beneath Dubai safely support the world's tallest building? To solve this problem, engineers created a massive reinforced concrete foundation. The foundation consists of a huge concrete mat, around 3.7 meters thick, supported by 192 board reinforced concrete piles. Each pile is approximately 1.5 meters in diameter and around 43 meters long. These piles extend deep into the ground and work together to support the enormous weight of the tower. The foundation mat alone required approximately 12,500 cubic meters of concrete. Once this massive foundation was completed, the engineers finally had a strong base from which the world's tallest building could begin rising. But another enormous challenge was waiting for them: how to design the actual structure. Challenge number 3. For the Burj Khalifa's design, Emaar brought in the Chicago-based architecture and engineering firm Skidmore. Owings and Merrill, also known as SAM. The firm had already designed many major buildings around the world. But designing a tower that would rise more than 800 meters into the sky was a completely different challenge. The structure had to support enormous amounts of concrete and steel, while also remaining stable against powerful winds. The solution was a unique structural system known as the buttressed core. The Burj Khalifa has a Y-shaped floor plan with 3 wings extending from a strong central core. Each wing supports and reinforces the others, creating a highly stable structure. As the building rises, its shape gradually changes through a series of setbacks, helping disrupt wind forces and reducing the twisting effect caused by powerful winds. This wasn't simply a design choice made for appearance. The shape was carefully engineered to help the tower remain stable at extreme heights. The engineers essentially designed the building to work with the wind, instead of simply trying to fight it. But even with this incredible structural design, the construction team still had another major problem to solve, and this time, the problem was concrete. Challenge number 4. The construction team continued building floor after floor. But as the tower became taller, getting concrete to the upper levels became increasingly difficult. The concrete had to travel hundreds of meters upward through pipes under enormous pressure. The solution was a specially designed high-pressure concrete pumping system. This allowed the construction team to pump concrete directly from ground level to the upper floors. The amount of concrete required for the Burj Khalifa was enormous. Around 330,000 cubic meters of concrete were used during construction. That's roughly equivalent to the weight of around 100,000 elephants. And in November 2007, engineers achieved a world record by pumping high-strength concrete from ground level to a height of approximately 601 meters. The concrete used at these extreme heights had to maintain its properties while traveling through hundreds of meters of pipes. The pumping system operated under enormous pressure, and the entire process had to be carefully controlled. Imagine standing on the ground and pumping concrete higher than most skyscrapers in the world. That is exactly what the construction team had to accomplish. But as the building continued rising, another challenge appeared. Challenge number 5. After several years of construction, the Burj Khalifa had already reached an incredible height. But getting workers, equipment, and materials to the upper floors was becoming increasingly difficult. Tower cranes and construction hoists had to operate hundreds of meters above the ground. At the peak of construction, more than 12,000 workers and professionals were involved on the site each day. These workers came from more than 100 countries and had to deal with extreme heights, intense heat, strong winds, and difficult working conditions. Every piece of equipment had to be transported carefully. Even a simple construction task became much more complicated when it had to be performed hundreds of meters above the ground. And while the tower continued climbing toward the sky, another major challenge was waiting. Challenge number 6, the Burj Khalifa was getting close to completion. The main structure was standing tall, but something was still missing: the enormous glass façade. More than 24,000 cladding panels were required to cover the tower. These weren't ordinary windows. They had to withstand Dubai's intense sunlight, extreme temperatures, and powerful winds, while also helping reduce the amount of heat entering the building. Installing all these panels was a huge operation. More than 380 engineers and technicians were involved in the exterior cladding work. At the beginning, workers could install around 20 to 30 panels per day. But as the team became more efficient, the installation rate increased dramatically, reaching as many as 175 panels per day. The façade eventually reached a record installation height of 512 meters. The glass panels also had an important job. Dubai receives intense sunlight throughout much of the year, so the façade had to reduce solar heat entering the building. The completed tower contains 24,348 cladding panels, covering more than 132,000 square meters of curtain wall area. Piece by piece, panel by panel, the Burj Khalifa finally began to look like the futuristic tower the engineers had imagined. But the top of the tower was still unfinished. Challenge number 7. During the final year of construction, the Burj Khalifa was almost ready for its official opening. The major systems were being completed, but the top of the tower still needed its enormous spire. The problem was that such a massive structure could not simply be lifted to the top by an ordinary crane. So engineers had to find another solution, and they decided to construct the spire from inside the building. The spire was assembled in sections and then pushed upward using hydraulic systems, instead of trying to lift one enormous structure from the ground. The engineers moved the individual sections upward and assembled them as part of the final construction process. The completed spire contains more than 4,000 tons of structural steel, and once it reached its final position, the Burj Khalifa achieved its full architectural height of 828 meters. Challenge number 8. Now the Burj Khalifa was finally complete. But years of construction had left the enormous building covered in dust and construction residue. The next job was to clean the exterior, and there was no simple way to do it. Workers had to use specialized maintenance systems to reach the thousands of glass panels spread across the enormous height of the tower. Cleaning the Burj Khalifa is still an ongoing operation. Workers have to move along the exterior and clean the glass section by section. Because the building is so enormous, maintaining the facade requires a huge amount of time and careful planning. And unlike construction, this job never really ends. The world's tallest building doesn't just need to be built. It has to be maintained again and again. I hope you enjoyed the video. Make sure to like the video and subscribe to Zirk TV for more interesting videos. Thanks for watching.